Hey, good afternoon, everyone, and thanks for joining us today. My name is Corey Hupp with the Concrete Products Group, and joining me today I have Adam Hutchinson with the Northwest Concrete Masonry Association and Brittany Thompson from NCMA. We're going to be moderating today's NCMA Foundation Unit Design Competition. Before we get started, we have a few housekeeping items to review. Hey, there's our smiling faces. All right, perfect.
All right, we are using several different platforms throughout the Midyear event to provide the best technology for each unique session. In this session, we will be using the Adobe Connect platform. All attendee lines are muted upon entry. Attendees may participate using the Q&A box on the right. Should you have any assistance needs during the session, please don't hesitate to call on the NCMA staff at the number on your screen.
Oops, wasn't me. Also, please note that today's session is being recorded, and by participating in this meeting, you are consenting to being recorded. Also, please note NCMA's antitrust policy, which can be found at NCMA Midyear event website. All participants are expected to exhibit professional behavior in compliance with this policy, as well as NCMA's anti-harassment policy. As noted on this slide, please refrain, intervene, or disengage from inappropriate discussion and report any concerns directly to an NCMA staff member. We also want to thank our very generous sponsors for their support of this event. You can see obviously their information here and at the bottom of the screen. And as you see them and do business with them, please thank you for their sponsorship so we can continue to do events like this.
All right, a little bit of background information about the competition. The objective of this masonry competition is to understand the relationship between material and form. There are no preconceived ideal solutions to this project, but there are some guidelines. To be eligible for this competition, each team must consist of a maximum of 4 students. These students are mostly undergraduates. Because of the uniqueness of this year's situation, each team was required to supply a video presentation of their product for judging. Each team was judged on the following. Box size. The unit must be designed to be casted in a 16 by 24 by 8 inch mold. Shape. Their block must be extruded when molded. Efficiency. The blocks are encouraged to use 90% of the box in each cycle. And stable shape. Units are weak when molded, but strong when cured, so sharp angles and thin walls are not advised.
All right, so let's talk about the competitors. The 4 teams we have this year are Ball State University, Iowa State University, Mississippi State University, and North Carolina State University. We're going to go through each team and watch their submissions and give a little comment on them. Starting with Ball State, the judges' comments, just for a little bit of background and things to look for, the judges' comment on this was the Ball State project was led by an investment into developing realizable strategies for recovery and sustainability in post-disaster third world countries. This motivation alone gives the project commendable presence. The exploration into increasing wind pressure and velocity through the Venturi effect to assist in cooling would be worthwhile to continue while folding in more research into the forming process and how a custom block might interact with standard blocks. So let's see that video.
Hello, my name is Colin Beresford. I will be walking you through this digital presentation. I want to start by thanking you on behalf of myself, Allison, and Tony for taking the time to still review these videos in this unprecedented time. It does mean a lot to us, and we hope you enjoy our project. To begin this presentation, we want to provide you a brief background of how we got involved in NCMA's Concrete Masonry Unit competition. Under the instruction of our advisor, Tony Costello, we explored the reconstruction of developing countries following the devastation of large-scale hurricane damage. Tony has a diverse background in architecture and has led many projects in Haiti that require unique solutions due to the lack of available materials sourced for construction in these areas. We specifically looked at the mud neighborhood on the Great Aboko Island in the Bahamas through a series of charrettes. From this process, we developed a full-scale design for a pre- and post-disaster relief center as well as a medical clinic. Allison and I then took on the task of developing a concrete masonry unit that could serve these hurricane-devastated communities in various ways while also incorporating some form of upcycling for the multitude of plastic water bottles that can be found following wide-scale disaster relief. To begin our design process, we researched a number of precedents that address the composition, overall form, and feasibility of the production of concrete blocks that incorporate plastic water bottles in their aggregate. The few you see below seem the most applicable as they didn't require large machinery to accomplish, yet still increase the strength of the CMU block through the recycling of average plastic products. After multiple iterations and lots of refining, the final design that we came up with is entitled Breeze Blocks. These units allow the water bottles to become a tool for passive cooling while also serving as a key between the CMU blocks. We also considered basic architectural principles like the use of the arch, which functions very well in compression to help offset the loss of surface area and structural integrity. Pictured are our final boards as well as images of half-scale models we fabricated. These models helped us visualize tolerance and potential weaknesses in the CMU blocks. The image below illustrates the potential of the Breeze block to serve as a passive cooling system. It utilizes the water bottles to channel the warm air through the mouthpiece, causing the air to speed up and effectively cool down. This concept is known as the Venturi effect and was a main proponent in our entire design. This image demonstrates the Breeze block's ability to be utilized as a porous paving block, which could be especially useful in places like Haiti during disaster relief, when the need to transport goods is of peak importance. It could also be useful in simply repaving walkable surfaces. The voids produced by the lack of bottles can be filled with gravel to solidify the surface while still allowing a source for drainage. The final application illustrated is the Breeze block planter. Like the paving system, the voids can be filled with soil and used for various agricultural applications. The overall assembly of the wall is comprised on 3 sequential parts: our typical Breeze block module with openings for the repurposed water bottles, a top cap, and a bottom piece that fills the slot where the water bottles would ordinarily be placed. Because these blocks act as a method of passive cooling, we envisioned a number of applications of where they could be used specifically in hot environments like Haiti. Not only could Breeze blocks be utilized as exterior walls of buildings, but also as separation walls around the waiting areas near medical and community centers. Now looking at the specific assembly of Breeze blocks, one strategy we incorporated was the use of the arch. This not only secures the water bottle in place, but as stated before, benefits the structural integrity of the brick as well. We also incorporated chamfered edges into the design for the ease of casting purposes. By avoiding sharp edges, we've decreased the possibility of chipping during the transportation and installation process. We've also introduced 3 holes at the top of the block for casting purposes. Like typical CMU blocks, these units would be installed and secured to one another with mortar or clay. The repurposed water bottles would also be secured to the blocks using the same substance. To conclude this presentation, we have included all 3 of our presentation boards in 10-second intervals if you wish to pause and view them up close. On behalf of Ball State, Tony, Allison, and myself, thank you again for taking the time to review this project.
All right, that was some pretty interesting video there. Next up, we have Iowa State with their inner block. To read the judge's comment, inner block was a powerful presentation of an ambitious concept. Lush rendering showed the developed architectural possibilities of proposal. It was clearly an inquiry into detail, light, air, and the inclusion of green nature. So let's see Iowa State interblock.
Experts, professors, and peers, we wish you each a cyclone's worth of greetings. We're all architecture students from Iowa State University in Ames, Iowa. Each of us are rising fourth years, and we're excited to share with you today our vision for a new concrete masonry unit block. I'm Jonathan.
Hi, my name is Bill.
Hi, my name is Shivan.
Hi, and my name is Nathan, and this is Interblock.
Interblock is a vision for a new CMU form which is effective both as a structural element and as a design feature. This opens new opportunities for solving design problems among construction professionals. Interblock introduces two compatible modules, the lock and the key. When interlocked together, these modules improve upon CMU's quality of modularity, simple production, and scalability by introducing new methods of construction.
The primary physical feature of Interblock's modules are their curves, a form expressed in the z-axis. The inspiration for this choice is the pelage, a form native to the Middle East, where channels of stone, lime, and cement help guide and store water in a hot climate. By exploring this precedent, we identified a form, blocks curving inward or protruding outward. We identified a reason, purposeful movement through curves influencing water, air, light, and nature. And we recognized how the manipulation of block direction enabled by this curving elevates interlocking modules across axes to make both an aesthetic and a functional statement.
We quickly realized that the block is not limited to the inside or outside, concealed or revealed.
Instead, it held this opportunity to live alongside the user, illuminating the textures of life through its display or arrangement.
Interblock fits 6 modules into a mold box, producing twice the number of blocks and utilizing twice as much concrete compared to a standard CMU. Fitting within the mold box allows for simple tooling and seamless production integration, enabling swift and scaled manufacturing of these modules. These are the dimensions of 2 modules interlocked together. We have paid careful attention to avoiding sharp corners and ensuring optimal structural thickness. The extruded voids within the blocks take the form of rectangles and circles, allowing for integration with structural reinforcement like rebar and grout, and additional technologies like lighting design.
The typical CMU block is placed side by side with others, connecting 128 square inches of area in a friction bond. In contrast, Interblock's modules are interlocked. The full contact of the curve creates a friction bond between these elements, with 448 square inches of friction bond. In physical models we made, the connection between blocks proved incredibly resilient, with a strong bond around the curve. The space between modules also left room for minor contraction and expansion across seasons. This ability to interlock with great strength enables unique applications across typologies.
Starting with the ground connection, we have envisioned a pelage-inspired water channel. This allows for surface-controlled water movement. Tubes can also be inserted through the extruded voids to conceal water piping and drainage within the overall project. The curves which tame the movement of water can also welcome a typical bench user. By arranging the blocks in concert with one another to form a comfortable seating surface with shallow backrest, the resultant bench is approachable. In this typology, blocks are interlocked and oriented in the Y direction. The blocks can also be oriented in the X direction. With the column typology, we explore this combination of interlocked blocks and verticality. By locating structural reinforcement at the block's core and securing them to one another with mortar, we have designed a high-functioning CMU column strong in compression. The roof typology explores the combination of CMU blocks held in tension. Envisioning post-tension steel rods through the extruded cores and held in place with grout, the blocks can form a repetitious field condition. Onto these blocks, plantings can be installed and lighting can be introduced through the circular extrusions.
In this bird's eye view of a celebratory CMU pavilion, we show these typologies combined together, conceived in our minds as a proving ground for these typologies and a celebration of the materials and its abilities. We have cited the pavilion in the desert and will show you experiences across perspective and weather conditions. Here we see plantings placed amongst the roof, water channel and retaining blocks sitting in the landscape. Moving inside, we are able to see a full range of humanity utilizing the blocks. From making music, to resting in the shade, to experiencing the oasis of flowing water and hanging plantings, the inside of the pavilion is dynamic across time.
Viewed in elevation, we start to understand the structure of the blocks purposely arranged in a modern vision of arches and the referential patterning. The use of interblock in particular elevate the typology of the column to be a form rich with shadow and texture. Viewed at night, we are able to understand interblock's seamless integration with structural reinforcement, electrical conduct for lighting, and landscape applications. The rainfall emphasizes the natural flow of interblocks formed among its site.
We exist in a moment of uncertainty, surrounded by a disease we imperfectly comprehend. Each masked encounter with a friend reminds us of our shared humanity and what it means to be alive. Humans exist to make, to connect, to touch. Interblock defines a new point of connection between blocks, changing the act of building with CMU from simple shelter to meaningfully designed living, inside and out. It is modular, it is simple to build with, and it is scalable with the imagination. As we sit in our homes, influenced by the natural flows of air, of water, and of light, Interblock exists as a direct response, bringing human scale and approachability to the strength and longevity of CMU. From the Iowa State team, thank you.
Great job, Iowa State. All right, up next we have Mississippi State and the Boyd block. One of the judges said, the Boyd presents the evocative results of a rigorous process. The students demonstrated acquiring a range of valuable skill sets during their project. The form of the block sacrifices a structural role in pursuit of its strength as a screen. And an original inspiring form was explored for functional acoustic value. A following iteration could begin with acoustic amplification as a goal and see what form falls.
Hello, my name is Jacob Gines. I'm an associate professor at the School of Architecture at Mississippi State University. It's my privilege to be able to introduce our team and their entry to this year's unit design competition. First, I would like to say thank you to NCMA for all of your efforts to ensure that this competition, as well as the mid-year meeting, is going off as a success. So thank you so much for all that you do, the support that you give to the students and to universities. You know, this competition is a really wonderful opportunity for our students to get some hands-on experience, understanding the particularities of these products and of concrete in particular. It also helps bring to the forefront ideas of innovation and creativity and thinking about the future of what are the next steps, what are the next things that this industry is looking at and doing in the future. I would like to thank NCMA as well for developing this virtual format that allows us to still present this material during this time. Our students competed in their local competition right before our spring break, and during spring break is when everything began to shut down, and so we were worried about being able to enter into this competition, and we're grateful for the opportunity to do this, even if it is in a digital format. We'd love to be there in person with you, but understand the unique situation that we're in at this time. Without further ado, I want to introduce our team, which is Jack Harrell, Kaya Perry, Ruthie Southall, and John Zeipen. 4 students who have worked tirelessly to develop a solution that is beautiful and functional. I'd also like to thank our industry supporters, Fred Dunand with Saturn Materials, who has been with us in this partnership for several years now, and we appreciate all that he does to help ensure the success of our students for the years in the past and the years to come as well. So without further ado, I'm going to kick it over to our students and let them present their project, The Void. Thank you.
My name is Jack Harrell.
My name is Kaya Perry.
Hello everyone, my name is Ruthie Southall.
Hi, I'm John Zeipen.
And we are third-year architecture students from Mississippi State University. Today we are bringing to you Void, the concrete unit based on Saturn Materials' Monarch masonry unit. Throughout our design and construction process, we were guided by our professor Jacob Gines, and we also had the chance to work with Saturn Materials, who mentored and sponsored our project. Professor Gines took our class on a field trip last semester to Saturn Materials. There, we met Fred Dunand, the president and owner. On our trip, we were given a tour of the production facilities, saw just how concrete masonry units were produced, and got to explore the family of masonry units Saturn has to offer. After the trip, we began a new project, a local competition for an innovative concrete unit design. The class was split into 12 groups with 4 people in each. Instead of using the standard modular brick measurements or typical gray block CMU size, we chose to explore a new design while utilizing the sizing for Saturn Materials' Monarch concrete unit, measuring at 3 5/8 of an inch by 3 5/8 of an inch by 15 5/8 of an inch. These dimensions allowed us to explore the horizontal nature of the unit while providing a beautifully proportioned surface area to develop and engage. The local competition hosted at MSU was judged by Thomas Stewart, president and owner of Architectonics, Terry Jones, the general manager of Geoproducts, Fred Dunand, president and owner of Saturn Materials, and our professor Jacob Gines, associate professor of architecture at MSU. When beginning the design process for our brick, our goal was simplicity in form and execution. We wanted to create a concrete masonry unit with one graceful gesture. After many meetings, models, and sketches, we came to the conclusion that our design would reference a torus, a surface of revolution generated by revolving a circle in a 3-dimensional space about an axis that is coplanar to the circle. The second goal of our design was to create a brick whose purpose extended beyond aesthetics. In the end, this overall curvature, along with the hole running through the center, allowed us to use this brick in a screen wall or in conjunction with soundproofing materials, opening us up to a world of acoustics.
So after getting our ideas down on paper, we knew our next step was essentially to begin 3D modeling this brick with the various forms that we had come up with as a group. And since we were consistently using the 3D modeling program Rhino in our studio course, we figured it would be best if we used that same program in this brick project. And rather than selecting one design on paper and modeling it, we decided it would make most sense if we took all the designs we came up with and started modeling them so you could see how each brick interacts with itself when digitally laid up and the various bonding patterns that you could do. And with this simple and elegant form, the brick really only needed like basic Rhino tool sets. We didn't need to do any sort of like external plugins like Grasshopper. The main torus shape on the front was essentially used 4 curves on each side, and then just lofted to make this little funnel type shape. And then the rest of the brick was just a box encasing that shape. And the simplicity of this unit design made the modeling process super quick, and it gave us a lot of time to start working on like the CNC machine and physically making this brick. So moving into the production side of the brick, we started first by laminating MDF sheets to form our block, which would then be used to CNC out our brick design using our Rhino 3M file. And then from there, we sanded the brick down, sealed it, sprayed a non-stick formula on it, and then bolted it to the bottom of our other MDF form that we'd created. And this would essentially be used to house the polyurethane that we'd be pouring in the empty space between the block and the form. And to get this specific volume of the space, we used a volume command in Rhino to calculate the negative space and get the exact amount of polyurethane that we would need to fill it with. And then from then on, we used this mold and this rubber framework to basically form all of our concrete bricks. We made our own mix for the brick using a wet concrete mix, and then gradually learned how to produce a sturdy brick by perfecting our water to concrete ratio, eliminating excess bubbles, inconsistent color, and cracking. And this process really showed us the importance of specificity in the materials and the ratios, and really how to go about them and create our final product.
For our concrete masonry unit, we intend on having a few different module coordinations for aesthetic purposes. The concrete unit can be oriented in a vertical, horizontal, running bond, 45-degree running bond, or any other alignment in which the brick runs parallel to itself. This concrete masonry unit can be used to alter light and sound. The masonry units are best suited for aesthetic purposes such as a partition wall in a garden or a museum, a screen wall which will be extended from a glass wall. This brick will also be good to use for the ceiling with a skylight to bring a beautiful pattern and control lighting for art galleries, museums, and other buildings that require a certain amount of heat, sun exposure. The concrete masonry unit is manufacturer ready due to working closely with professionals during this process.
Throughout the design process, we continually noticed the possibility of an acoustic effect through the horn-shaped hull of the concrete unit. To better understand what capabilities our design had, we reached out to a local acoustic engineer, David Woolworth. Initially, we believed that the shape of the hull would act as a high-pass filter that would allow mostly high-range frequencies to pass through by funneling them through the hole, and simultaneously we thought that this would make the low-range frequencies blocked or really diminished in effect on the other side of the wall. After performing some simulations, we have determined that, by and large, the hypothesis was correct. In an outdoor setting, we believe that passing through the opening of the unit, sound would be amplified by roughly 5 to 10 decibels from a range of about 500 hertz to 5,000 hertz. And on the other side, it would be rather filtered and similar in volume to any sort of screen wall that you've seen in your everyday life, in a garden or so. The effect is, of course, limited based on the surroundings of the wall. The wall, like if it's an indoor space, the walls that are around it, if you're walking down a hallway, the screen wall's on your left. If there's a path around the wall, that's going to, of course, diminish the amount of amplification that's seen because that path would allow sound to subvert the use of the wall. In a larger outdoor setting, like a major park, the determinations so far are a little more unclear. In theory, the effect should be about the same. However, there are a lot more variables to consider, like neighboring buildings, heavy vegetation, environmental turbulence, etc., etc. We believe that overall the acoustic amplification seen in a larger outdoor environment would be diminished comparative to the indoor environment. The barrier that you would need in an outdoor environment would need to be pretty large to achieve a similar effect. Of course, it would be scaled because there's so many more variables, so much more ambient sound outside than there is inside. But however, there's still a few possible use cases where the narrative fits, like an outdoor amphitheater or a backing wall for a outdoor theater space, outdoor presentation space. Those are very possible applications for this unit. In more controlled environments that are outdoor, like a central courtyard area, we suspect that it will be relatively similar to the indoor environment, but still diminished a little bit by those outdoor variables.
Hello, this is Fred Dunnan, President of Southern Material LLC, Columbus, Mississippi. Our engagement in the community has brought close collaboration with Mississippi State University. It has been evident that this partnership benefits students and reveals the potential of the industry through NCMA product design competition. Students have been dedicated to bring the best through teamwork, competing with 15 other students during the local competition. MSU School of Architecture, with active participation of Assistant Professor Jake Johns, has brought inspiration
spectacular showing from Mississippi State. Up next, we have North Carolina State with the chalk block. The chalk block answers the question, how much is enough? How much is enough consideration? How much is enough innovation? And how much is enough presentation? Chalk block is simply believable, showing respect for the typology and strength of the typical. It does not stop short of an ambition to add new opportunities and achieves a strong new form ready for production assembly. Please note there's no sound or commentary during this video, so do not adjust your computer sound settings.
That was really well done, NC State. Now I want to introduce you to our jury who took the time to evaluate all these great submittals and work towards ultimately a winner. We had Jason, Jim, Kevin, and Dan. So thank you, gentlemen, for your time to evaluate this and be part of this program. Before we get into announcing the winners, preparing to announce the winners, obviously everyone did a great job. They were really exciting videos to watch, and ultimately they're all winners. I did want to comment, one of the judges made an interesting comment that fantastic video presentations. These students have a second career in multimedia and graphics, so they can always fall back on that. They did a wonderful job.
All right, coming in at number 4, we have Ball State with the Breeze Block. The Breeze Block provides unique versatility. Very few units can function equally as a screen wall and as a permeable paper. And at number 3, we have Iowa State with Interblock. Interblock columns are a perfect central feature of any space, interior or exterior, providing structural function and a novel aesthetic texture.
All right, coming as we build the suspense, coming in second, we had Mississippi State. Love the hands-on prototyping of the units, provided not just great visuals, but real-world practical engagement for the students. And drum roll, please, coming in at number 1, in North Carolina State with the chalk block. Highly practical and easily incorporated into construction using conventional CMU, a new spin on the shadow block. Well done, everyone.
Again, congratulations to all the students, and a big thank you to the NCMA Foundation for putting on this competition. Also, again, thank you for joining us today. We want to thank the students that participated, the jury for sharing their insights, and our sponsors for supporting the event.
And also, please complete the poll before you leave this session. There's going to be a poll link that pops up as soon as we're done. Your feedback is very important to us so we can do things well and better in the future. Next up, the next event we have up from 7 to 8 p.m., we have the social networking hour with the Golden Garlic competition. This could be really engaging. I've heard some good things about this. And after that, then we have 8 to 9 p.m., we have a social networking hour, barbershopping with Bob and Terry. So look for the next event. Thanks, everyone, for joining. Appreciate you. Have a beautiful day.
Thank you.